how many milliliters of 1-butanol CH3CH2 CH2 CH2OH with a density of 0.8110 grams per milliliter are required to prepare 725 milliliters of a 0.350 molarity aqueous solution of this solid. So before we do any conversion, we should understand what this means. So 0.350 m solution means that we will have 0.350 moles of the solid, right? And I should probably write molarity of 1-butanol, right? Because that's what molarity is, right? So I'm going to write 1-butanol, the solid. So this means that you have 0.350 moles of 1-butanol over 1 liter of the solution, right? That's what M stands for, right? So basically M saves you a lot of space, because instead of writing this, you can write it simply like that, but we need this in order to convert, right? Which is why I explained what this means. Okay, so you need to find what? You need to find the number of milliliters, so question mark, milliliters of 1-butanol. Okay, so you're going to take 325 milliliters, right? Because 325 milliliters is not butanol only, it's the solution, right? You will prepare 725 milliliters of the solution, right? So you should write solution. So now the next conversion that you're going to do, you're going to convert first of all from milliliters to liters, right? And we need that because as you can see, the molarity deals with the liters and not milliliters, right? So we need to convert this. So 1000 milliliters of the solution takes 1 liter of that solution, right? So we successfully took that away. So now we convert it to liters of the solution. So now the next thing we're going to convert it to is going to be using this, the molarity, right? So as you can see, the liters will go on the bottom, 1 liter solution. On the top, 0.350 moles of 1-butanol. Okay, so we successfully got rid of this. Now the next conversion is going to be what? So we converted to moles of 1-butanol. Now we're gonna have to find this is given as 1 mole of this butanol, right? So in 1 mole of 1-butanol, we need to find the number of grams. And why grams? Because as you can see, the density will help us convert from grams to milliliters, right? And that's exactly what we want, right? Because the question asks you to find the number of milliliters of 1-butanol specifically, right? So we will need this conversion of the density. But in order to use this conversion of the density, we need to use we need to convert from moles to grams, right? So how many grams in 1 mole of this, right? You will use the periodic table. There's carbon, how many carbon atoms? 1, 2, 3, 4, right? 4 carbon atoms will be multiplied by the formula mass for the carbon, which is 12.011 grams per mole, right? So doing that, the same thing for the hydrogen, except the number of hydrogen atoms is what? It's 10 right here, and there's 1 oxygen, right? So you're going to combine it similarly and add everything up, and you should get 74.1228 grams of 1-butanol, right? And again, you get this by having 12.011 times 4, the carbon, 10 times 1.00794, the formula mass of hydrogen, 1 atom of hydrogen, and then 15.9994, right? So when you add all that up, you will get 74. Okay? So as you can see, you get grams per mole exactly, and that's exactly what the 1 mole of this weighs, 74.1228 grams. Right, so you successfully got rid of this. So now grams of butanol. So one more conversion and you're done. From grams to milliliters, right? So the grams will go on the bottom, 0.8110 grams. You might say, but wait a second, it's on the top here, and why are you switching it? I'm switching because the way where the grams wound up being on the top. So in order to cancel, we will need to switch this fraction, right? And that's the beauty of it, right? When you perform conversions, you can actually switch your units if you are required to do so, right? So in this case, you are required to do so. You need to switch this fraction, right? So you will need to have the units of grams in the denominator, not the numerator. So that, and on the top you will have one milliliter, right? So and let's add butanol, and let's 1 milliliter of 1 butanol. So and then we will need to round the final answer to 3 significant figures, right? So that goes away, and we're left with exactly milliliters of 1 butanol. That's what the question asks you to find, right? So doing that on your calculator, you will get 23.222 something. You will round to the nearest tenth, because that's going to be 3 significant figures. So 23.2 milliliters of 1 butanol. Thank you so much for watching. Hope this was helpful, and see you in the next video.